Pardon? Sorry, I can't hear your voice. It's like kind of cracking, like in the middle, like when you speak, it like goes off and then it like comes back again. What an atom is like the smallest part of an element. Yeah. I'm not sure. Like I haven't studied this yet, so I don't know. It's just one of my learning outcomes. Okay. Wait, pardon. So an atom is like single because it just, but then what does it mean by that diatom is two atoms, like joined together? Okay. And are they like, they're not shading with each other, are they? Just like next together. Okay. So wait, what is that? Okay, so diatom is a form of. Okay, I'm just got. Yeah. Wait, so seven. So what are the seven elements of? No, but like, I mean, like, what are these like? Why, like, what do you mean by seven elements when you wrote down seven elements? And I mean, like, are these seven elements of diatomic atoms or something? Like, what does it mean? Yeah, yeah, that's what I meant. So five. What does STP stand for? Okay. And what is the last one? Chlorine. Okay. Okay. Yeah, I've got those down. So these are two exceptions. So I put in like brackets, not in the form of gas. Yeah, I'm just copying it now. So bromine, iodine. Okay. And what does this two mean? That's like, is that like in the subscript, is it, or like, yeah, okay. Yeah, I've written it down. Okay, all diatomic um, atoms are non-metals. So 1 second. So yeah, okay. Okay. And what group are halogens in the periodic table? Okay. And is group zero noble gases? Just asking. Okay. So yeah. Yeah. Okay. No. Okay. So is that the only triatomic element or no? Okay, so basically you're saying oxygen O3. Like, what does this have to do with? Yeah, so in all of, okay, so none of the other ones form triatomic. Okay, so shall I write only one like that is triatomic, like in bracket? Okay, I've written it. Wait, so what are these some other? Okay. Is the third one dilithium? Yeah. And is like is just asking like because this is like generally like I'm just wondering that like are there like before like elements when there's like di tri tetra like or some like these prefixes, is that relating to like how much atoms they have? Yeah, okay. Yeah, I could because I kind of remember going over these prefixes a while ago, but like not that much in depth, so that's why. Yeah, so it just basically means how much atoms there are, right? Okay. Yeah, I've written it down. So these are not stable. Okay. So because of that, these also break very easily, chemical bonds. Their chemical bonds break easily. What does it mean by like when solids are evaporated? Like just at that point, they like obviously like I know what evaporation means, but like their chemical bonds are broken easily. Like so, no, I'm not familiar with that. Pardon? No, I don't think so. Like I've not heard of it. So it doesn't go to liquid. Okay. Can I write that down? They go from solid like directly to gas. So is this just when you just leave them out in like the open, or is it? Yeah. So can I just write down maybe just these tablets? So just so like if I'm looking back, I get an idea. Is it cam? Okay. And the other one is maptaline. Okay. Yep, I've written it down. Yep. Not bonding. Well, technically, I mean, I guess it was like more like bonding. Like I know, because that's like about like when two like what you call it, two like atoms like they bond, cause it to complete an electronic configuration. But it's like the covalent like it says here like in a like a learning outcome part. So like this is just like learning outcomes. So like I'm just going to read one of the parts that I need to know like for the course. So it says I can state the covalent compounds bracket solid liquid solution. Like I can state the covalent compounds do not conduct electricity. So what does that mean? Like the covalent compounds do not conduct electricity. Yeah, they're like the like when two atoms like join together to complete an electronic configuration. But like, are they like more like pardon? Two bond metals? Yeah, wait, isn't it between one? I don't know if this is wrong or not, but is it between one? So two non-metals. Yeah. So basically, like let me try and think. So it's kind of like um it's like let's say if atom like let's say carbon, right? Like the electronic configuration like at that moment is like since the atomic number is 6, it's two what you call two electrons are in the first shell, and then in the second shell there's 4, but 8 there needs to be 8 in like the second shell, or like yeah, or like I don't know how to explain this. So basically, like in like completing an electron shell, you either see if it's easier to take away like the electrons or to add more electrons to like share more with other. And basically, um, since it's not going to lose or gain an electron like carbon, it will form like a covalent bond. I don't know, like because that's what I learned from like previously, like in this like studying from another tutor. So that like carbon is 2 4, so that's why like it's not gonna lose or gain. Instead, it's gonna form a covalent bond. So let's say if it shares with hydrogen, um, or it could also be like another element and it like shares the electrons from that element and like share together. So no, right? And because none of like them are metals. Pardon? Yeah. Um, I don't really understand your question. Like if like because covalent compounds, it says generally that they do not conduct electricity. So then it doesn't become a covalent compound, does it? It becomes like an ionic compound. Yeah. Yeah, like I'm not sure in that much detail, but I just know that like covalent compounds, like it has to be both, like both of the atoms have to be non-metal. That and then I'm just like writing a quick note of this again. Like both atoms that are shared have to be non-metal. Yeah, for covalent bonds, be non-metal, and then like I'll just quickly write another note. So about ionic compounds. So in fact, before writing about ionic, like the small note, uh, because because both the atoms that are shared have to be non-metal. Covalent compounds do not conduct electricity. If I write that. Okay, so and then for ionic compounds, are they is like I'm not sure if this is right. I'm just trying to remember. So is it that one of them is non-metal? I mean, and one is metal, or like in ionic compounds? Yeah. So I'll just quickly write that as well. Because they are like also being shared, like an ionic bond, atoms are being shared. Okay, so I've wrote about that, but then also that so ionic compounds uh still they in a solid state, it says like here in my learning on outcomes, it says that I can see that ionic compounds do not conduct electricity in a solid state but do conduct electricity when dissolved in water or when. Okay, so should I write that as well, like pardon? Sorry, I didn't hear the last part, like cut off. Okay, when dissolved in aqueous. Is that correct? Like when dissolved in aqueous or when molten? Yes. Instead of water, do I write aqueous or no? Okay. Okay. So ionic compounds do not conduct electricity when solid. Uh, but do when they're liquid. Well, sorry, when dissolved in aqueous or when molten. Okay, so I've just wrote that as well. Wait, what's this aqueous? What's the spelling of it? Is it AQ? Oh, okay, yeah. Thanks. When dissolved in aqueous or when molten. Okay, yeah, I've written that down. So should I? Is there anything more that, so that part's like covered, but then there's another learning outcome I'll just read. It says I can state that electric current is a flow of charged particles. So yeah, so that's yes it is. I'm just like reading through. So it says I can state that electrons flow through metals and that ions flow through solutions. Hello? So yeah, like basically like what's that mean? So like already kind of in biology, I think, I'm not sure, but like isn't it the movement of ions from low to high concentration, like against a concentration gradient, that's active transport, right? So then like that's how ions flow through solutions. But then yeah, right? That's like it's because that's how it is. But then is there anything that I need to know about like electrons flow through metals? Yeah. So this is no, I was just asking, is this just pardon? Okay. So yeah, so well, because so electrons flow through metals. So, but like, what does this mean? What you've like written? I'm kind of confused. Like that electronic conductor. Yes. Okay. So okay, so you're saying that the one that electricity passes through uh metals, then that's like an electronic conductor. Okay, and when they pass through other non-metals electricity, then it becomes an electrolytic conductor. So can I write that in a sentence? Does that make sense? So when electricity, yeah, passes through metals, uh, it so what becomes an electronic conductor? Like what should I write? So like as a note. Yeah, yeah, they are like non-metals. Like I've written that down, but like in a sentence, should I write when like for like separately? So when electricity passes through metal slash graphite, uh, like blank electronic conductor. So like what should I write for electronic conductor? That is like so basically I want to take a note of like this a bit more in detail. So, like, should I write when electricity passes through metal slash graphite? Like, that's what I know so far, but then how can I end that? That it like ends with electronic conductor. Like, end that sentence, like, for a note for me to write down. Like, I don't know. No, no, no. I'm like saying that like I've written these two down. I'm saying is in a sentence, like if I'm looking back at it like later on, like in a few days or something, then if I write down when so like this like this is like explaining each separate conductors. When electricity passes through like just metals, let's say, then what does that mean, like electronic conductor? Then it becomes electronic conductor. So when electricity uh, goes to metals slash graphite, like how should I write a note about it? Okay, so when electricity passes through metals, there is a flow of electrons. Okay, I'll just write that down. So there is a flow of electrons through the metals, right? So if I've written that when electricity passes through metals, there is a flow of electrons through the metals. So like I've just written that kind of. But then when electricity passes through, I don't know, should I just like say solutions? Like even like I have the other like whole written note down, but I'll just like pick one thing. So when electricity passes through solutions, um there is a flow of ions in the solutions. Does that make sense? So, like when electricity passes through solutions, there is a flow of ions through them. Okay. Okay, so right, I've written that down. And now, so yes, that's that part. And then what is the formation like? It basically, like it says here, I can describe the formation of ions in terms of atoms losing and gaining electrons. So what is that meaning? Like, do I just need to know that in order for an atom to be like complete, that it needs 8 in its outer like electronic shell? Okay, so every atom or every element? Like atoms in an element need to be completed. So so every atom needs to be completed. Should I just write that as a note? Hello? Yeah, so is it every atom needs to be completed? Is that just basically what it? No, but like the every, like what I mean by that is like that it needs to be like 8 or like whatever is required on the outer shell that needs to be complete. Okay, so the outer shell of an atom needs to be completed. Is that the way to word it? So the outer shell of every atom needs to be completed. Okay, and then um okay, and then it says um it says then I can state um it says that I can state that solid compounds can be ionic or covalent, and that compounds which exist as liquids or gases at a room temperature are covalent. So, like, what does it mean by this? It like the only thing it's saying that so solid compounds can be either ionic or covalent, and so whichever are liquids and gases at room temperature are covalent. Yeah. Okay, so it can't be the metals can't be like liquids or gases like that are then yeah. Okay, yeah, basically that kind of pretty much sums it up itself. But then the next one is saying, I don't know, I haven't heard this before, like this like word when it says I can state that the ionic solids exist as lattices of oppositely charged ions. I don't know what that means. Yeah, it says I can state that ionic solids exist as lattices of opposite charged ions. So, like lattices, Lattices. Yeah, that's like what I mean. I don't know what it is. I mean, we haven't went like. So, should I write this for like lattices examples, like what lattices is? So, lattice basically means like structure, like it's like a structure. The formation or just structures? Okay. So basically, like, so H2O, so that has, so this, so that would be NaCl's lattices, like the lattices of NaCl. So those are the lattices of NaCl. Okay. So, but you've written, I mean, you've written H2O, so like, okay, so what does two compounds have to like do with it? Two hydrogen and, I mean, three hydrogen, one oxygen. Shouldn't it be four? Wait, so basically, is it, does it, what I'm trying to say is since, like, in the H2O example, there's 3 points, so that's like two, but there's like total, there's uh two hydrogen and one oxygen. So, okay, so that's why it stands for two hydrogen like points and one oxygen. So I'm asking, is it like two of them H stand for H and then one of them for O? So the, yeah, like I'm not asking the order. It's just like the at like the elements that are in it. So then NaCl, so that's sodium and chlorine. So that's just like random, or did you like specifically draw that? Because NaCl, isn't that like, wouldn't that just be two or no? Yeah, but you've drawn quite a few, so I'm just asking, like, yeah, a limited portion of salt which is required. Okay, so this is like if it was more of like it, but it would only be two. Okay, so that's like drawing if there's lots of them kind of, right? Like I'm saying that would be like if there's not like let's say the limited portion amount of salt, like that's what I mean. So like not one grain, that's like a few, like not grain, but not just one little piece, like that's a few pieces, right? That's what that would look like, right? Okay, and then obviously it can just expand, right? As much quantity there is. So as the quantity gets more, the structure gets bigger. So as the quantity increases, like the structure gets bigger, right? Hello? So like as the quantity increases in like that compound or something, then the structure gets bigger, right? Okay. So is this the compounds, right? Okay, so when it means ionic solids exist as lattices of oppositely charged ions, what does that mean? Hello? I said that it says, like, as we were finishing off, because you just explained what lattices are. So, my whole question was what does it mean by ionic solids exist as lattices of oppositely charged ions? Oh, wait, so the solids basically exist. So ionic solids exist as lattices of oppositely charged. So they have to be lattices of oppositely charged ions, ionic solids. So if I write this down, so ionic solids are are lattices of oppositely charged ions. But how do you know that like how is it that Ne is plus and Cl is minus? Like I'm just asking, like, is it just because of like in a data book that you'd find that, or I don't know, like how would you know if it's negative or positive, like an element? Yeah, so asking how would you know? Hello? Just me write it down. Okay, so how do you know if an element if an element is so how do you know if an element is positive or negative? Yeah, like how would you know, like if it's positive or negative? So, but like not a compound, so I'm just meaning an element. So, like Cl, right? Like just the element. How did you know that it's like negative? That's what I'm asking. So, because of the electronic configuration, but how do you find out in that? Is that because, um, let me see. Is that because Na, right? The configuration. Yeah, sodium. It starts off with 281, but then it needs to lose one electron. So if it's losing an electron, it then becomes positive after. Is that why? So what would carbon be then? Like carbon, like a positive or negative, since it's 2 4 is the electronic configuration that starts off with. So like if it was just carbon, right? So like how would I know if that's positive or negative? Hello? Okay, is it like better now? Okay, so like does this make sense if I say so how do you know if carbon is positive or negative as its electronic configuration starts off being 2 4? Yeah. Yeah. Right. Sorry. Wait, so if they lose them, then what happens? They're solids, but if they gain electrons, then yeah, so if it loses, then it becomes positive after, but if it gains it, then it becomes negative after, right? Yeah, so like I already know that, but then what would I do when it comes to carbon? Yeah, I'm pretty sure. And like, yeah, so carbon, because it can gain or it can lose, but it can gain as well. So, like, I'm not sure what I would put it as. So I'm saying that can it gain, like, is carbon positive or negative? How is it positive? Because if it gains 4, then it becomes negative after. Because carbon can't, it like, it needs to be a covalent bond, right? So it can either gain 4 or lose 4. I mean, not like, yeah, so it either gains 4 or loses 4, doesn't it? Hello? So then how do I know, is it negative or positive? Yeah, but like, if it's just carbon, right? And it's like, then if it doesn't say like what's happening, then how do I know if I put a plus next to it or a minus next to it, like negative? Okay, but then do I just pick one? So this has to be with a compound. So, but it says ionic solids exist as lattices of oppositely charged ions. It doesn't say anything about compounds. But do lattices have to be in compounds? Yeah, but like lattice, like, okay, so that changes it then, because if carbon and hydrogen were together, mm, but like in most cases, then it would be gaining it. So it would become negative, right? Like always when it shares. So whenever carbon bonds like to become a compound, uh, then it will gain, causing it to then become negative, right? Okay, yeah, I just wanted to ask about that. If like that's how I know. Okay, yeah, yeah, of course. It's fine. I don't know what the problem was with the audio though today. Like even it's not like clear, like it kept on cutting up. Okay, right. Right. Have a nice day. Right. Bye. Good day.